Ricardo Jean says, I know this shadow. Oh, yeah. Oh, yeah. So let's get into it here, everybody. So while all of you are over there trying to solve this thing live on this episode of Model Monday Live, I am going to attempt to solve this thing here using Onshape. So you can solve it using any 3D CAD system you want. I'm going to attempt to solve it using Onshape. And of course, this model is found over at tootalltoby.com in the Practice Models app. So I'm going to say click here to get started. You can sign up for a free account, and we've got several models that are free for anyone with a free account. And then of course, if you really enjoy what you're seeing in the app, you can sign up for the Practice Models Premium membership and unlock the entire library. But what we've done is up here at the very top of the app, we've added a section for featured challenge practice models where all the functionality of Premium is available for anyone with a free account. And we are now going to attempt to solve this model here, 250601. Click here to practice. And we can see no one has done it yet. So we're going to try to become the first person to complete this practice model. It's a tier 6. It challenges us to use the whole tool, the multi-material, patterns, shell, sweep, symmetry, thin walls. There's a lot going on in this challenge. It's called Bath CADDY, and we saw this model during the tournament, but we have changed it a little bit here for Model Monday Live. So let's click here to begin and go. What is the mass of this multi-body part or assembly in XXXX grams, and the tolerance is plus or minus 5 grams? That's a pretty generous tolerance, I gotta say. I think we could probably get through this thing. Now, we notice it down here, there's kind of a title block. We've got our 3 shelves here, which are all the same part. You know they're the same part because they have the same model number. And we've got our 2 tubes here, which are the same part. They got the same item number. And we see that the material density down here is 1060 aluminum alloy, 2,700 kilograms per cubic meter, and ABS and 1020 kilograms per cubic meter. And so we can imagine that this model is probably going to be some kind of a sweep to create these legs, and it's going to be some kind of an extrusion with a shell to create this shelf here. So a model like this, you know, this is a tier 6 model. I don't think we're going to normally we go into a game plan where we talk about some fundamental things like where should the origin be. Here what I'm going to do is I'm going to use this function in the Practice Models app, open in new window. That way I get a nice big preview of the drawing here that I can work with without having to, you know, mess up the scale if I'm zooming in and out. So I've got this nice big preview here of the drawing. If I was going to decide on a location of the origin, you know, for me, the drawing here, the model has this center line symmetry in 2 directions. So I would probably opt to just drop the origin right down here, right down at the base of the model. And then I'll kind of work my way up to create this sweep and to create this shelf here. So as far as kind of starting or where should the origin be located, that's where I think I'm going to put the origin. As far as my starting sketch, I'm not even sure what it's going to look like yet, but I think I'm going to start by creating the geometry of the tube. Then I'm going to create the geometry of the shelf, and then I'll start creating the patterns. And then finally, since this model does have symmetry in 2 directions, I think what I'm going to do with this model is I'm going to try to create it by creating just 1/4 of the model. So I'm not going to worry about all this geometry here. I'm just going to work on creating 1/4 of the model. Now, what makes a challenge like this a little bit tricky is that we're working with tubes. You can see here that the tube has an OD of 28 and an ID of 22. But what makes it challenging is that our dimensions are going to the kind of max dimension here. So you see we've got a max dimension here of 428, a max dimension of 353, an inside bend radius of 40. But when you go to create a sweep, a lot of times what you'll do is you'll create the sweep going through the center of the tube, not to the outside and not to the inside. And so that's something that you're going to want to think about. And maybe in an advanced tutorial, we could go in and create a variable table or create a variable for the tube diameter so that we could use that in an equation in some of our dimensions. But for today's example, I'm just going to take that dimension 28 and I'm going to be regularly cutting it in half to 14 so that I can get an offset for the center line of my tube. So we'll see what that looks like here in just a minute. But for now, let me move this drawing over to my second screen. I think I've taken enough time to come up with a game plan. Let's bring up Onshape here and let's attempt to solve this thing and we'll see how long it takes us. So I'm going to bring up Onshape here. Let me bring this up like so. And I'm going to bring up my my keyboard cam as well here so that you guys can all see, you know, any keyboard shortcuts that I'm using. I think that helps when you're watching the tutorial if you can see what kind of keyboard shortcuts I'm using. All right, and let's move this chat here just a little bit so we can see the chat as the answers are coming in. All right, and CMYK is here, says howdy, another fellow FPVer. And we got Paulo Coco here, says I'm a little late. Hello, hello. And yup, that's me, says, hey, better late than never. Yeah, I completely agree with that sentiment. All right. Well, now that our keyboard cam is shown, let's get into it here. We're going to say create document, and we're going to call this thing 25-06-01 Bath Caddy. And we're going to say create a public document here. Now, this is a public document, which means that if you ever access Onshape and you go into your documents, you can search the public space for this number, 25-06-01 Bath Caddy. And then you would be able to look up my model and kind of look through the history tree and see what you come up with. So now, like I said in my game plan, I'm going to start out by creating the tube information first. Now, I think what I'm going to do here to kind of make life a little bit easier for me is I'm going to start out by taking the top plane. I'm going to press the S key. I'm going to press plane, and I'm going to create an offset here at 14 millimeters. So that gives me an offset from bottom, 14 millimeters. So offset from the bottom. So that's kind of like my new top plane. And then on that plane, I'm going to begin a sketch, and I'm going to press the N key to get normal to, and I'm going to create a rectangle that represents the overall dimensions of the frame. So the overall dimensions of this frame are 353, enter, 428, enter. So that's the overall dimension of the frame. And then I'm going to take that rectangle and I'm going to do an offset, and I'm going to offset that to the inside at a dimension of 14 millimeters. So basically what I did there was I just kind of gave myself the location of the tube information that I'm going to be creating next. So what that lets me do now is I can exit that sketch, and I could call that something like layout max footprint. And now I can create another sketch on that offset plane, begin a sketch here, and I can create a line here that starts at this layout right at the midpoint even, come down to about here, come back, put my mouse over the endpoint, come around here with a radius, and now that radius is going to be an inside bend radius of 40 plus 14. So 40 for the inside bend radius plus 14 for 1/2 of the tube thickness or the tube diameter. So I'm going to press enter there. I'm going to move over, not all the way to the center. I really only need to move over a little bit. This is just going to be a stub. So I'm just going to move this over to maybe 10 millimeters, and then I'm going to hit escape. And then we'll take this line and this arc, and we'll press T for tangent, and there we go, nice fully defined sketch. Now, the reason I'm doing it this way is because Onshape doesn't have a 3D sketcher that will let me easily create both of these in one sketch. So what I'm going to do is make this sketch here that I just created, and then I'll make a second sketch on a plane out here that will come up like so. So I'm just going to make that first sketch there like so, and then I'm going to exit that sketch, and then I'm going to go to my my front plane, S key, begin a sketch, and I'm going to create the sweep profile. So I'll pick up this point here, single click, move my mouse over, single click, that's going to be 28, enter, single click, move my mouse, single click, that's going to be 22, enter. And then I'm going to exit that sketch. So now for my sketch names over here, click on the sketch, Shift N, we'll call this one lower sweep path. And then click on the other sketch, Shift N, and we'll call this one lower sweep profile. So now we've got our sketches name. That's going to make it easy for us to pick those. So now I could jump into the sweep command, and then here for the regions to sweep, I'll click the profile, and then for the sweep path, I'll click the path, and boom, there we go, the beginning of our tube. So we hit the green check mark there, and we are done with that. Now, what I'm going to do is I'm going to I'm going to hide that lower max footprint, and then I'm going to show the sweep path. So this is where it's good to kind of name your sketches. Then I'm going to click the front plane. Then I'm going to click this point, and then I'm going to press S key plane. And when I choose S key plane here, you can see that once I choose S key plane, the result here is that I end up with a plane right there at that point. Let's see here. Victor K saying, Toby, is the first 42 not working? To my knowledge, it is working. If it's not working, we'll take a look at it at the end here. But to my knowledge, it is working. But maybe somebody else in the chat can confirm and let Victor K know if the first 42 is working. So now what I did was I created an offset of the front plane right to that point. And again, the way that I did that, let me Control Z here for undo, just because I think it's a cool workflow. I picked the plane, I picked this point, I press the S key. I've customized my S key to have the plane command in there. And Onshape is smart enough to recognize that because I picked the front plane first, and then I picked that point. Onshape's smart enough to recognize that the type of plane I'm trying to create is the plane point option. So I don't have to go through this menu and pick it. It just automatically picks it because of my pre-selection. Hit the green check mark, and boom, now I've got a plane out there for that next sweep path. Chris S in the chat says, Toby, can you pause so I can go to my work meeting? I wish that I could, but I will edit this video and release it as a standalone tutorial for you. So now I'm going to go over here to this plane, and I'm going to S key begin a sketch, and then I'm going to S key begin a line, and I'm going to create a line that comes over here like so. Single click, come back, touch the end point, come away, single click, type in the diameter or the radius here, 40 plus 14. And then I'm going to move my mouse up here like so and single click. Then I can hit escape, and I can take this line and this arc and press T for tangent. And then I can create a dimension. The dimension is going to go from the floor. So from the top plane, you can either pick it here in the graphics area or pick it here from the tree to this end point here. And that dimension is going to be the max height of 746, enter. And then there's going to be a dimension that goes from the right plane. So you may need to hit escape here and take this line and move it over to if it's over on this side. Oh, and look, it also looks like it's not vertical, so I got to make that line vertical as well. So move this over here, click on this line, press V for vertical. And whoops, looks like I picked up a relationship by accident here. Yeah, look at that. Looks like that point has a vertical relationship to the origin. So just delete that. And there we go. Now I can move that over. So now what we're going to do, now that that line is moved over a little bit in this direction, and it doesn't matter how far, you can move it even way over here if you wanted to. Then what we're going to do is we're going to create a dimension that goes from the middle plane here, the right plane, to this line here. And that dimension is going to be the gap. So the gap is 28 millimeters between the tube divided in half and the tube diameter divided in half. So it's going to be 28 divided in half plus 28 divided in half. So it's going to be 28. So 28, enter, and there we go. There is our gap to that. It's really like the center line to center line gap really should be like 56. Should be 28 times 2. But we're only going half of that because we're only doing half the model. So now that sketch is nice and fully black. And so now I'm going to hit the green check mark. And now I'm going to create another sweep. So I go sweep here. And the cool thing about Onshape is that for my sweep profile, I can just pick this face here. And then for the sweep path, I can choose this sketch here that we just created. And look at that. That gives us that sketch or that sweep for that tube. So we hit the green check mark. And now if we look at this thing in a front view, so shift 1 for front view, we can see that it is flush with the bottom. You know, this bottom plane here is flush with the bottom of our sweep. And we can also see here that if we look at this thing from the side, or really from the top, if we look at this thing looking down from the top, we should see that our layout with the max dimensions is also lining up with the outer boundary of that tube. So I always think it's good if you're not sure, if you're having a hard time like mathing out what the max distances are, do what I did here. Just go through and create a layout sketch. And the only reason you're using that layout sketch is to kind of just capture those overall dimensions. It's going to make it a lot easier also if the customer comes to you and the customer says, hey, this shouldn't be 353, this should be 420. So you could change that and then hit the green check mark and your geometry is going to update. And now you have that wider frame for that customer. So it makes it easier, you know, when you're making changes. If you've got those overall dimensions, it's easier for the customer to visualize it. So don't be afraid to make a layout sketch. It's a really useful tool in 3D CAD, regardless of what 3D CAD system you're using. Aaron C in the chat says, dimensioning the edges in the drawing, dimensioning off the edges of the pipes was diabolical. Yes, thank you. I'm glad that you guys appreciated that during the tournament. It was the finals, guys. We gotta have some challenges during the finals. All right, so now we're gonna go to the top plane. We're gonna press the S key, plane. We're gonna type in a distance of 110, 110 off the bottom. That's gonna give us the lower face. So Shift N, plane, lower face of shelf. Here, this sweep here, we could call this one tube part 2 or section 2. Then this one would be like tube section 1, tube section 1, tube section 2. Using Shift N here to do that rename, tube section 2. So now at a glance, we can kind of tell what the geometry in the tree is being used for. So now we've got a plane here, lower face of shelf. And so we can take that plane and we can begin a sketch, get our view normal 2 here, and then we can create the geometry for that shelf. So we're only creating 1/4 of the shelf here. So instead of this being a total shelf width of 270 or 267, it would be 267/2. And then for the distance in this direction, instead of being 388, it'll be 388/2. So that gives us our shelf in that direction as well. And now we can take that geometry and S key extrude, and that's going to come up to a height of, our shelves are 85. And then it's going to be a new. This option here for add versus new means that we're able to create multiple parts here in one single Onshape part studio. So currently we have one part, which means that our shelf is going to merge to our tube. You'll notice it even shows in the same color. But when we choose the option for new, what'll happen is that shelf will change to a different color and we'll get a new part down in the part studio. So we say new here, and then we hit the green check mark, and now we've got 2 overlapping bodies here in our part studio. So this part here, Shift N, we'll call this one tube. And then this part here, Shift N, we'll call this one shelf. So now we've got a tube, now we've got a shelf, and now we are ready to create some additional geometry for that shelf. So S key fillet, we'll do this outer corner here first. We'll give that a radius of 55, enter, enter, and then S key fillet. We'll put in a fillet down here on this lower edge. That's gonna have a radius of 25 around the bottom, enter, enter. And now we can create a cut extrude here. So we can pick this face, S key, begin a sketch, N key to get normal to. And we can take this edge of the tube here and we can do an offset entities. So, you know, you could just type, you could create a circle here and you could make this circle radius of 15. It's called out radius 15 tube clearance. But really what you should do here is you should make this a 1 millimeter gap. So we make this a 1 millimeter gap between the tube and the shelf, because that way, if the tube diameter increases, your circle will increase so that your cut for clearance in the shelf will also increase automatically. That's the correct way to design multiple parts together in context. And it'll save you a lot of time. You know, if you're designing something that's going to be 3D printed and it's 3 or 4 different parts, if you create these relationships, it makes it so much more flexible because you can change one of them and they're all going to update. So we're going to take that edge and we're going to offset that to 1 millimeter, hit the green check mark, and there we go. Oops, sorry, I meant to hit the green check mark for the offset. So I exited the sketch by accident. So hit the green check mark for the offset, and then we can turn that into an extrude, S key extrude, and that's going to be a remove through all. And then here for the merge scope, we're going to say that we want the shelf to be affected by that remove, that cut extrude or that remove. So we hit the check mark, and then that would be called something like cut clearance in shelf for tube. And then what we can do is we can hide the tube. So very easy to hide these bodies when they're named tube and shelf. A lot harder when they're called part 1, part 2. Okay, so take your time and rename your bodies. It'll make your life a lot easier. So we can hide that tube, and then we can say here that we want this to be a fillet. So S key fillet, and that fillet is going to be on that edge, and it's going to have a radius of 12 on the outside, 6 on the inside. So a radius of 12 there, and then we're going to do a shell command, and we're going to say we want to shell this, and we want to shell it by removing that face and that face and that face. So 3 faces here, and that shell is going to be at 6 millimeters wall thickness. There we go. Boom. So now we can show our tube again. And now at this point, we can decide if we want to create the pattern first or if we want to create the hole first. You probably want to create the pattern first because the hole is going through all 3 of them. So Aaron C says, Toby, I'm disappointed you didn't use indent. Yes, yes, exactly. You should have used indent for that for sure. So maybe I'll do another tutorial where I do it using indent. But getting back to my point here, I think that what you're probably going to want to do here is make the pattern first, and then after you make the pattern, then make the hole. So you can make the hole as a pattern as well, but I think you want to make a pattern of the shelf body first. So we'll click linear pattern. For our entities to pattern, we'll pick the shelf. This is going to be a part pattern. So part pattern, feature pattern, face pattern. This is going to be a part pattern. And then the direction here, you can just pick the top plane. So in Onshape, you can pick a plane and have that drive the direction. So the instances are going to be 3, and then the distance here is going to be 270. So there we go. Pattern of 3 of those bodies. Hit the check mark. And now we can begin a sketch on the front plane of this thing. So front plane, S key, begin a sketch, and we can create the sketch for the holes. So we can get normal 2 here, and we can create the sketch for this hole here. So it looks like if I go to the circle command, single click, move my mouse, single click 10, enter, and then I can create a distance dimension from this shelf here to the hole, and that distance is 20. And then from this point here to the center line, so this could go to maybe the right plane. So see there, I was able just to click the plane out of the tree and then grab a dimension to that plane, and that the distance is going to be 56/2. So it's just going to the center line of the tube, but I didn't have a dimension on there, so I just wanted to make sure I call out that dimension. So, but it is the center line of the tube as well. You can kind of intuit that from the drawing. So now that we've got that hole there, now we can decide, do we want to make 3 instances of the hole here, or do we just want to do it as a pattern? I'm going to do it as a pattern just because it lets me do the reapply feature trick. So it's a good learning tool here during this tutorial. So I'm going to say extrude, and that extrude is going to be remove, and that remove is going to go through all, reverse direction. And then we're going to say that the merge scope is going to be merge with all. So that just means I don't have to come over here and say punch a hole through this body and punch a hole through this body. I can just say merge with all, and then that means it'll punch a hole through all bodies that it's going through. So that gives me that first hole, and now I'm ready to create a pattern. So we're going to do linear pattern here. The type of pattern this time is going to be a feature pattern, not a part pattern. So feature pattern, and then the features to pattern is going to be this hole. And then the direction of the pattern, we can once again pick the top plane. And then the distance is going to be 270, and the number of instances is going to be 3. We can see in the preview that it's going the wrong way. The pattern looks like it's going in this direction. So we click the reverse direction. There we go. And it should be good now, but it is showing up in red. So what do we do when a pattern shows up in red? We click this check mark here, reapply features. And most of the time in Onshape, that takes care of it. So we hit the green check mark, and there we go. That hole has been patterned into all 3 locations. And we're pretty much on the home stretch here. All we need to do now is just mirror, merge, and calculate and apply the material and calculate the mass. So for the mirror here, we can say we want to mirror this part, this part, this part, and this part, and we want to mirror them about. We could just pick the front plane here. And then there's an option here when you go to mirror them about, you can say you want to use the option for add, and then you could just say, I think if you just say nothing, it'll merge them together. So if I don't choose anything here and I hit the green check mark, boom, they get merged together. So we still only ended up here with these 4 parts. So you can do a little bit of experimentation to figure out what works and what doesn't. If you have to do merge with all, or if you have to do like go through and pick the bodies from the merge. But yeah, it should end up just working if you just do the mirror. I see an update here from Vicky Chong in the chat. Issue fixed. I think that is referring to the top 40 or the first 42. So the first 42 should be working now. Thank you very much, Vicky, and thank you very much to the dev team for fixing that. And so now we're going to do another mirror, and this time it'll be this part, this part, this part, this part, and this part. I'm not sure if this is actually going to work or not. I didn't try it out this way before. So we'll pick the right plane, and let's just hit the check mark and see what happens here. So it looks like I'm going to end up with some extra parts here in the tree that I wasn't expecting. So if let's see here. We want this one too. There we go. Yeah, so it did end up, I'm not sure if I can get them to merge together in one single step. So I think instead what I'll do is let's do add here. 1, 2, 3, 4. Oh yeah, it did work. Sweet. That's what we wanted. I was just on new. I should have been on add. So what I'm doing is I'm focusing my eyes down here on the parts list to see how many parts I'm ending up with. So for new, I ended up with 8. And then for add, it did merge them together. So I'm only ending up with 5. So that's what I want. So awesome. Point for Onshape. And so now I'll take this body here and this body here, right click, assign material for 2 parts. And that's going to come from the Too Tall Toby custom materials library. And that is going to be the material of 1060 aluminum alloy for the tubes. And then I'm going to take this part, and this part, and I'm going to right click and assign material for 3 parts. And that material is going to come from the Too Tall Toby custom material library as well. It's going to be ABS, and we hit the check mark, and now we are ready to perform a mass properties on all 5 of these. So let's see here. We are coming up with a mass of 5971 grams. So 5971. Let's go into the app here. So back into the app here. 5971. 5971. And did we get it correct? Oh yeah, we got it. Congratulations. Your answer is correct and within tolerance. And it looks like we did it in about 24 minutes. Wow. So tier six challenges are no joke. That is a long run, but 24 minutes. I'm glad that I was able to get it done. And here we go. We're going to say submit. We're going to get 1 point on the leaderboard. And we can now come down and we can see 7 people have completed this model. And if we take a look at the top or the first 42 here, we can see that it looks like it was Aaron C. who completed this model first. Congratulations to Aaron C. 134008. And wow, look how close these guys were coming in here. Aaron C, 134008, and then Victor K, 46. So just less than 40 seconds on a tier 6 model. That is so awesome. And then Ricardo coming in 2 minutes after him. This is like the white whale here for Ricardo also, because when we were during the tournament, Ricardo wasn't able to finish that model. So that's got to feel good for him to have finished it now and gotten the correct answer. So awesome job, Ricardo. That's what we like to see. And look at even Vicky Chong getting in here and modeling this thing up in Onshape. Well done. Wow, impressive. Very impressive. I didn't realize you were such a CAD guru. So congratulations to everyone who got on that board, and great job to Aaron C. GG to Aaron C. for finishing out that model. And good job, guys. That was a lot of fun. That's a fun model. I hope you guys enjoyed that tutorial. If you did, be sure to like, be sure to subscribe to the channel. And that does bring us to the end of today's episode of Model Monday Live. Good game to everyone. Good game to Aaron C. And 5973.